Welcome back. Maybe. It's been a while. With the drill press all done, I can finally drill those holes I mentioned in the last chassis video. It's time to mount the tranny. I bought these 1/4 inch front and mid engine plates off of Summit Racing, and I will admit it did take me a while to figure out how to even fab a mount for this thing. It only comes with holes for the motor in it. You drill all the others, but when you are building a frame from scratch, you gotta figure out what the mount should even look like. How strong does it need to be? How many bolts should it use? Like you got to see last time, I made a frame for the transmission engine plate. It may seem a little flimsy, but these tubes are 1/8 inch wall DOM tubing, and are more than capable of handling the torque of far more powerful motors than I'm putting in here. For rigidity and stability under longitudinal and lateral acceleration, rather than just using the big 2-inch tubes like the rest of the frame that will eat into my already microscopic pedal box, I'll be tying it into the roll cage with the same tubing I made it out of. Considering the front of my transmission was supposed to sit at this junction of the tubes, right at the firewall, that's where my mount will be. My mount will sit on the backside of the motor plate, adjacent to the bell housing flange. The motor plate isn't very tall, but my engine sits pretty high in the car. This means that the motor plate will only be able to bolt to the upper portion of the frame I built for it. It's why I needed to build a frame for it in the first place. Remember, the center of the crankshaft of my motor sits 7 inches above the center of the frame rails. As the frame is 2 inches thick, I subtract 1 inch as it is from the center, then measure 6 inches above that point. According to this drawing, this bolt hole center sits very close to the center above the crankshaft, so I can grab my engine plate and mark where that point is. Now that I know where my engine is on the plate, I can put that mark exactly 6 inches above the bottom of my new frame, so when it's welded in, it's 7 inches above the frame center. Now that it's marked out, I can figure out where it's possible to put bolt holes. I figured I have roughly 5.5 inches of vertical space to do this. After some research online and a little bit of calculating, I figured out at minimum 2 3/8 inch bolts per side of the plate would be more than safe enough to hold the motor in. So, of course, I figured 3 per side, or 6 total, on this plate would be good. Now here is my current problem. I can't exactly just drill a hole in this tubing and stick a bolt through it. That would put a lot of stress on a small contoured face of the tubing and likely make it impossible to torque the bolt correctly. Instead, I cut these 1/8 inch plates and welded them on each side of the frame to give myself a flat area to work with. I tried it with TIG first, as I'm still not comfortable with MIG, and let's just say it didn't go that well. I tried it with MIG and it took a fraction of the time. Now that I have my plates welded in, and I know where the motor plate sits on them, I can mark out the holes. I evenly distributed those 3 holes with 1/2 inch of clearance to each edge of the welded in plates, and then marked those holes down the line. I made a mistake here though, as the edges of the welded in plates aren't perfectly straight. Naturally, the bolt holes I mark out based on them will not be perfectly centered on the tube. What I should have done is mark the tubing center with a tube marking tool before the plates are welded on, then drill the holes based on that, and as each plate is welded on, re-drill the holes. Either way, it's done, and as this will be used as a template for drilling the motor plate, it'll still work. Now back to the motor plate. I laid it flat on my table and put the frame on top. Then using that drawing again, I figured out where the bolt holes on the motor plate would be relative to the bottom of the frame. I held the frame down and used a transfer punch on the holes, then used an actual punch to really drive them in. With my new press, drilling the holes was a breeze, despite the fact I didn't know the right speed for it. As you can see, with my 25/64 drill bit, my 3/8 inch bolts drop right in place. Now that I know everything fits, I can cut the motor plate to snugly fit the frame. I gave myself a 1/8 inch border to the frame, marked out the corners, and drew straight lines that I would use as my cut lines. I tried to be careful with the angle grinder, but the debris it threw as it was cutting felt like thousands of little needles stabbing me, and I didn't do the best job. Aluminum is pretty soft, so I just cleaned it up by hand with a file, and actually got the edges looking pretty nice. With the edges all straightened up, I can use my air chamfer tool on both the edges and the bolt holes. During the fabrication process, naturally the aluminum got pretty scratched up. To prep for paint, I sanded the whole thing down with 150 grit sandpaper that also cleaned up the edges even further. I went over it again with the sander to take off any scratches the air tool left and wiped it down for paint. I made another mistake here by using my crusty touch-up spray gun because I didn't want to bother cleaning my big boy gun. Well, frankly, there's no other way to put it, it died on me here, and spattered quite a bit. But it looked plenty good enough to leave it as is. This is by no means a show car. I let that Cerakote cure for a couple days and got to work on the rear mount. Now, my original plan was to mount the transmission from the top. However, this requires a special tail housing, as the original tail housing cannot simply be rotated to get the bolt holes on top. This was, however, something that me, in my infinite genius, did not check until after fabricating the mount for it. So I got to cut that a couple times until it fit in the right spot. Now, you're probably wondering how I'm gonna get the transmission out with a engine in front and a fixed mount underneath the back. The simple answer is, I won't. If I have issues, I'll just throw the whole car away. Obviously, I'm kidding. This mount is a placeholder. I can't design the final mount until a bunch of other stuff is in place. That unfortunately requires this transmission to be fixed in place to take measurements for that stuff. Here comes the fun. The rear axle. Originally, I had planned to put a Ford 8.8 in, and even pulled one to install. However, as I was doing research and designing my suspension, I found this was not going to be a good idea. The mounts would be huge, requiring large amounts of space under the car. The axle was going to take over $1,000 just to put the gear I wanted in it with a limited slip differential and a shorter axle, not including that I'd have to narrow it, fabricate suspension components, buy shocks and coil springs, or buy actual brakes for it, pushing that well over 2 bands just for this setup. And it's still a solid rear axle. Solid rear axle has its uses, but for a car I want to handle like it's on rails, it's less than ideal. After a little perusing of my options, I figured out I could, for all intents and purposes, put any rear end I wanted in here, assuming I could make a driveshaft fit. And that's not that hard. I stumbled upon this mighty beast. Not the price though. You're reading that right. $550 for a complete S550 Ford Mustang independent rear suspension subframe, with free shipping from Florida to my godforsaken state of California. That is including the suspension components, such as coil springs, shocks, actually good rear size brakes, 315 gears I would have installed anyway, and a limited slip diff. Again, for $550 plus tax. All in a subframe I can just bolt into my car and call it a day. No suspension geometry calculations, no cutting and welding the axle housing, just straight gas, for less than what I spend on Taco Bell each month. So yeah, frankly, I'd have to be pretty dumb to not absolutely diddle this opportunity. It's basically perfect for what I want. It's a little rusty, but otherwise in what appears to be good shape. Looking at the mounts confused me a little bit, and the lack of pictures online didn't help. The bolt holes on these look ginormous. I actually found out that they're just manufactured that way. The bolt used is significantly smaller than the hole, and again, it just comes that way from factory. They sell sleeves online to tighten this up, but seeing how I have a 3D printer and some filament lying around, I just printed my own. The stock bolts are 14mm, but most of my car is Imperial, so I printed mine for 9/16 inch bolts instead. As there is no clear center to the subframe, I made sure the subframe mounts were symmetrical relative to the suspension. As far as I can tell, they are, and with that in mind, I can start drawing it in CAD. Once again, without many resources online, I don't know if the subframe is installed at a slope or level to the rest of the car. To my understanding, they are level. The front mounts I measured are 40.5 inches apart, center to center, and the rear are 37.75 inch apart, but significantly higher in the subframe than the front mounts. What I struggled with here was figuring out how much higher those rear mounts are supposed to be. I can't just slap a straight edge on the bushings, as those aren't super precise, and any change in angle will change my distance by a lot. I took that measurement off the bushings, then tried my best to level out the subframe using the top box frame rail, then, with a leveled out straight edge, measure that distance. Keep in mind I didn't measure vertically from center to center, as these mounts are actually different heights. The front mount is designed for a double shear mount, but the rear mount has a metal plate for mounting in single shear. Now that I know how the mount is designed, I need to figure out where the mounts go in my car in terms of vertical and longitudinal positioning. I wish I could say longitudinal is easy, but it's not. The mounting of the lower control arm is actually slanted upwards looking at the front, so that means when the suspension compresses, the wheel moves forwards in the car. This means unless I know where the wheels are at normal ride height, I don't know where they are. On the flip side, rubber suspension bushings are always tightened at normal ride height, which told me, at the very least, the control arms are at a negative angle at that height. After a little bit of research, I was able to approximate that the wheel sits 1 inch below parallel at normal ride height. In other words, I need to mount the subframe at a height where, with the lower control arm sloped downwards at roughly 4 degrees, the wheel center is 7 inches above the frame. In the event my measurements are wrong to the point it can't be ignored, I can shim the subframe or swap to coilovers to mess with these numbers. Either way, it's pretty unlikely I'll need to change anything big here. Finally, with this figured out, I can proceed on modeling the subframe in relation to the rest of my frame. It's not quite as simple as just connecting the front and rear mount, but pretty close. I need to add attachment points for the coil springs and shocks. I found online that the springs are 670 pound weight. As I've estimated my car to weigh 2,400 pounds when it's all done, with a 50-50 weight distribution, that means there is roughly 1,200 or so pounds over the rear wheels, or 600 per side, causing about 1 inch of compression total. Now, unfortunately, it's not that simple. These Mustangs have a motion ratio of 0.5, where the wheel moves twice as much as the spring does. What this means is there will be at least 2 inches of spring compression. As far as suspension goes, dynamically, I'd also want to take into account wheel rate, but considering I'm just trying to figure out static ride height, 2 inches is what I'll go with. I picked 1 inch because I'm not welding in the perches quite yet, and adding an extra inch to dial in my ride height will be very easy to do with the design. I just need to know approximately where I need to run my frame. And who knows, maybe I'll put coilovers on it. Measuring the unloaded length of the springs at the normal ride height I figured out earlier, I subtracted that ride height plus an 1/8 inch for the spring plates, and that told me where the tube that sits on top of the springs needs to be. Here it is. It doesn't look like much, but it's just a guide for fabrication. Unfortunately though, this design involves not just numerous angled cuts, but rotating those cuts relative to one another. In other words, this will be the most painful part of fabricating the frame so far. To help me in my efforts, and to not go insane, I printed 2 tools to help me. One was a clocking tool for tubing, and the other was a center marker. I can say at the very least I'm glad I finished the bandsaw, because I am going to be needing it. A lot. Without going into too much detail, here's how I did it. Find the angle I want, divide it by 2. The two tubes that intersect will each have this angle cut into it, therefore adding up to the total angle. If there are two angles that are anything other than cut in the same direction or 180 degrees apart, after making a clocking mark and the first cut, rotate with the clocking tool on that clocking mark to the other cut and make it. The issue is that in the process of making these cuts, you have to mentally flip the angles around a bunch of times unless you're reading exactly off of a guide, and it is exceptionally easy to lose track. I like to think I am pretty capable of 3D modeling things in my head, but if my scrap bucket is anything to go by, it's a little bit too much for me to handle without writing some of it down. I'll explain this as a similar version of the first tube I cut just to put it into perspective. You have one cut that is rotated 15 degrees counterclockwise from a vertical center line. Then you have another cut only 10 degrees off from vertical center line, so one cut points down and to the right. The other cut points up and to the left, but not as much to the left as the bottom one does to the right. As this is a horizontal bandsaw, any cut I make is 90 degrees to the direction it'll actually point. So I take my clocking mark, rotate it 15 degrees counterclockwise to make a cut that is ironically clockwise relative to the mark in how it points if a tube were to extend directly from that cut. I then need to flip the tube around, rotate it 180 degrees, rotate it 10 degrees counterclockwise from a opposing clocking mark, and cut again. If I want to make the tube for the other side of the car, I need to change directions of rotation for every step. Can you see how I got lost a couple times in this purgatory? But once I figured it out, paired with a couple more mistakes, such as clocking marks deciding to disappear, I got the pieces cut. I found marking the ends with a scribe was good insurance in case the clocking mark died. With my first couple of tubes cut, I now need to cut the plates that the subframe bolts to that are welded to these tubes. At first I was going to do this with my angle grinder, but the designs of these plates have no cuts over 45 degrees, so they can be cut on my bandsaw. Considering I was going to be making 2 of each plate, I decided to make things easy for myself. I extruded the sketch of the plates in Fusion, then 3D printed them. Now I can just trace them out and have very accurate plates. 3 cuts later, I have my 2 plates. Now I get to really try my new drill press, and not just some small holes in aluminum. The bolts I picked are grade 8 9/16 inch coarse, because they were most similar in strength to the 14mm ones the subframe originally used. I can't say I know the right speed for certain, but it cut pretty clean, and neither the bit or plate were even warm. With the plates done, I now get to weld the tubes. The challenge here was holding them in place as I welded them. I found these magnetic arms that were on sale at Harbor Freight, and bought 2 packs of them. The second weld I did was this plate, that sits perfectly perpendicular to how this tube would be when it's installed in the car. This plate bolts to the top of the subframe, and conveniently gives a great surface for an angle finder to clock the rest of the tubes. The second cut also did not need to be clocked. It was on the same plane as the first cut. I did, however, find out now that I didn't leave quite as much room as I thought I did for the coil spring, so I ended up cutting these and extending them out another 2.5 inches. The third cut, however, does need to be clocked. If the angle is even slightly wrong, the tube will end far away from where it should. This is where those plates I welded on earlier come in handy. Laying the tube on its side with the angle finder, I'm able to find how much to rotate the assembly around the new tube I'm welding. The final tube is on the same plane as the last one I cut, so I can just make sure that the total angle of the cut is correct and weld it on. With the final tube in, I can weld the rear mounting plates on. These plates are, of course, at the same angle as the front plates, flat with the car, so I can use the angle finder on both of them to get them to be the same. The only part I struggled with was making sure the plate was square to the tube I was welding it on, especially when my clocking marks disappeared. I did mess up slightly on this rear plate for the left assembly, but it makes little difference in fitment. And I'm sure you're wondering, well, after all this tedious work, does it even fit? Yes. The bolts slid in effortlessly with the sleeves installed. Now again, you're probably thinking these plates are a little flimsy to be mounting the whole subframe to. And I'd agree. This is the entire rear end of the car. This is all that secures my wheels and rear axle to the car. And it needs just a little bit more work. My first issue to address would be the rigidity of these plates. They're 1/4 inch thick, which is pretty solid. However, they are not supported vertically, and only secured on one side. This makes them quite strong against horizontal movement, but very weak against vertical movement. They also put a lot of stress on a small section of these tubes. So, out comes my 3D printer again, and I started testing out plates to stiffen it up. Once I found my design, I cut those out too and welded them in. Both a top and bottom plate for the front, and only a top plate on the rear, as I've yet to determine my full frame design in the back. While it's generally not a good idea to have a plate terminate in the middle of a tube, and especially one of this thickness, these tubes are 1/8 inch thick. So while it's definitely possible for them to crack, I think it's safe to say they'll go out swinging. Before I can get to fitting up the new rear axle, I do need to cut out the old tunnel that housed the old rear axle. There were quite a few interlocked pieces of sheet metal here that did make it tricky to remove. For some odd reason, it also burned through cutoff wheels, and I used around 20 just to get through this section. I do want to emphasize how long this stuff takes. This was a 2-day job, and took me around 6 hours total just to cut this section out. You might think those aren't long work days, but after frying in a suit full of metal shavings, you wouldn't want to be there for long either. With all this done and fitment verified, I grabbed a dear friend to help me for the next 6 hours to get my new rear end under the car. We started with moving the old axle out of the way and getting the new axle off the pallets and onto some casters. Then we jacked up the car, fought a couple yellow jackets with brake clean, and rolled the new axle under the car. As the car swings while the jack lowers it, it makes it a little difficult to get the longitudinal position of the subframe correct, but a little shimmying around got it close enough for me to start cutting any sheet metal that might interfere, and there was quite a bit. Then came the challenge of centering the subframe in the car. See, longitudinal position, or rotation around the vertical axis, isn't the problem here. I'm going to cut 2 tubes of equal length and weld them into place between the subframe and the main frame of the car. This subframe will automatically be square to the car just from that. My current problem is going to be finding the center of the original frame I put into the car, and then finding a way to center the subframe based on those findings. I also need to make sure the height of my subframe is correct, as well as making sure it is level and not tilted up or down. As I know my main frame is fairly accurate, I found the center of the tube at the very front of the car, the center of the rear bulkhead tube, and used a string and a plumb bob to make a mark on the rear of the car as to my center line. I leveled, or at least tried to level out the car before doing this. This center line may not correspond exactly with the body of the car. That is okay. The frame being straight is more important than the body, which can easily be changed to fit the frame. With this mark made, I used magnets to hold tension on the string, which is now the center of my frame. After taking a few measurements of the subframe, I found the subframe is indeed centered on the suspension as an assembly, meaning if I measure halfway of the total width from these speed holes, suspension fixture points, or mounting holes, I will find a fairly accurate center of the subframe. With that mark made, I can use the plumb bob again to center the subframe. Now it's time to cut the last 2 tubes of this section, the one that connects my subframe mounting assemblies to the rear bulkhead. These tubes have a notch made for the bulkhead, and then a clocked cut that mates to the subframe tubes. This was, however, not my brightest decision. Not making the tubes, no. I cut those just fine, they turned out fine. But the problem was attempting to line up the subframe with the car, without having these tubes in place first. I thought welding them only once the subframe was lined up would be easier and allow me to compensate for any errors in my fabrication. But I severely underestimated how difficult manipulating the subframe was, and overestimated the amount of error there would be in the frame I made. It was a huge pain to get into position, and near impossibly so to the level of precision required to make a good frame, and my frame rails were actually quite accurate. Remember how I said I don't have to worry about the longitudinal placement of the subframe in the car because of these tubes? Well, it's precisely because I didn't weld them on yet that I did have to worry about it. So, after another hour of shimmying the subframe around like an ape, I finally figured out I should have just welded it in the first place. The next day, after welding those tubes on, and after remounting them to the subframe, I was able to, by myself, line up the subframe and weld it in. It's level to the frame, it's square with the car, and to my understanding, centered within 1/8 inch of the rest of the frame. Well, as everything is in place, I'm not quite done yet. I don't fully trust letting the car sit on the subframe at the end of this 2-foot long bar. It's flexing quite a bit, and I'd hate for that flex to mess with any of the other measurements. So I printed some more templates and welded in some reinforcing plates. This stiffened up this joint significantly, and well, that's it for this section. Don't think that this is all for the frame back here though. There's still a lot of tubing and plates that are gonna have to go back here for both the shock towers and the roll cage. But that's the easy part. This isn't even half of it. It was quite a bit of work, and once again made me do a lot of things I had never done before. Things that seem simple until you try it, and find how little information there is online on how to do it. But it's done. It turned out quite well as far as I can tell, and I never want to do it again. But if you're not outside your comfort zone, you're not learning. For a final note, I want to say the next video uploaded to this channel will not be car or tool related or adjacent. It is entirely unrelated to the car build, but it is a project I've been working on for almost a year now, and I think it'd be a little silly to make a whole new channel just for that. So keep in mind, if you watch this video and you're subscribed, you probably won't be interested in it. However, the next 2 videos after that, at the very least, will be about the car build.